Good morning, friends. In this class, we will discuss about working principle of DC machines. We will discuss. So here, DC machines are classified into two types. One is DC generator, and another one is DC motor. So what is DC generator? What is the input of DC generator? So for DC generator, input is mechanical. Input is mechanical. Output is electrical. Similarly, for DC motor, input is electrical. Output is mechanical. So DC machines are classified into two types. One is DC generator, another one is DC motor. So in this class we will discuss about DC generator. Working principle of DC generator. See, for DC generator, for any machine, they are having two windings. One is field winding, another one is armature winding. Generally, field winding is placed on pole core. In DC machines, field winding is placed on pole core. Armature winding is placed on rotor. Rotor. See, here, what is pole core? See, this is pole core. And this one is pole shoe. So where the field winding is placed? Field winding is placed on pole core. This is called field winding. Field winding is placed on pole core. So which type of supply given to the field winding? Always we will give DC supply to the field winding. Whether it is DC machine or AC machine, whatever. For field winding, always we will give DC supply. If you give DC supply, which type of magnetic field is developed? Already we discussed. In starting class. See, suppose if you take a winding and if you apply DC supply, DC means time invariant current. See, if you apply time invariant voltage, the current passes through the coil is also time invariant. So which type of magnetic field is developed? Magnetic field developed in the coil is constant. So constant magnetic field is developed. When if you apply DC. DC means constant current. Suppose if you apply AC supply to the coil. AC means it is varying with respect to time. Means if you apply time varying voltage, current passes through the coil is also time varying I of t. So which type of current passes through the coil? Time varying current. Time varying current. So which type of magnetic field is developed? Time varying magnetic field. Time varying magnetic field. Sorry. See here, if you give DC supply to the field coil, which type of magnetic field is developed in the field coil? Constant magnetic field. So that here flux lines passes through the coil. Flux lines passes through the coil is, see, these are the flux lines passing from north pole to south pole. This is north pole, this one is south pole. North pole, south pole. See, flux lines are passing from north pole to south pole. Flux lines are passing from north pole to south pole. So these are the flux lines direction. These are the flux lines direction. So flux lines are passing from north pole to south pole. So up to here field winding is about field winding we discussed till now. So what is the conclusion? Take one coil, and if you apply DC supply, then which type of magnetic field is developed? Constant magnetic field. So here magnetic flux lines are passing from north pole to south pole. So let us, this is north pole, this is south pole. So here flux lines are passing from north pole to south pole, north pole to south pole. This is north pole, this is south pole, let us. So these are the flux lines. So flux lines are passing from north pole to south pole like this, like this. Understand? So this is about field winding. So in any DC machine, they are having two windings. One is field winding, another one is armature winding. Field winding is placed on armature pole core and given DC supply. Always given DC supply. If you give DC supply to the coil, what happen? Magnetic field is developed. Which type of magnetic field? Constant magnetic field. So here constant magnetic field is developed and flux lines are moving from north pole to south pole. Constant flux lines are moving from north pole to south pole. North pole to south pole. So this is about field winding. Next, coming to second one. What is the second one? Field winding is over, which is placed on pole core. So coming to armature winding. Coming to armature winding, which is placed on rotor. Which is placed on rotor, armature slots. See, if you take armature conductor, this is armature conductor. See, this is conductor A, B. This is conductor AB. This is conductor AB, and this one is conductor CD. This one is conductor CD. This one is conductor CD. So suppose this is north pole, this is south pole. In between I placed one conductor. See, take pair of conductors, 1 turn. So here, see, if you take two conductors, let us see, initially conductors are stationary and flux lines passing from north pole to south pole is also constant. Both are constant, stationary. So is there any EMF induced in the conductor? Is there any EMF induced in the conductor? So what is the working principle of DC machine? What is the working principle of DC machine? If you place stationary conductors in the constant magnetic field, there is no EMF induced in the conductor. When the EMF is induced, according to Faraday's law, if one quantity is stationary, another quantity should be varying with respect to either time or space. With respect to time or space. See here magnetic field is constant. Why? Because we are giving DC supply. So we can't change magnetic field with respect to time or space. It is fixed. So which one we can vary? We can change the conductor direction. So what is the input for DC generator? What is the input? Input is mechanical. Input is mechanical. So if you give mechanical input to the DC generator, if you give mechanical input to the DC generator, if you give mechanical input means if you apply the force on conductor, what happen? Conductors will rotate. Conductors will rotate. Conductors will rotate. If you apply mechanical force on conductor, and if you rotate in clockwise, these two conductors will rotate like this. If you rotate in anti-clockwise direction, these two conductors will rotate in anti-clockwise direction. So here mechanical input given to rotor and electrical input given to field winding. See here, if you give mechanical input, what happen? Conductors are rotating. So in which direction conductors are rotating? See, if you apply force in clockwise direction, what happen? Conductor AB moving in upward direction, conductor CD moving in downward direction. Means this is conductor AB, this is conductor CD. This is moving in upward direction, this is moving in downward direction. If you apply like this, if you apply force, this is moving in upward direction, this is moving in downward direction. So here force applied on the conductor, it is moving in upward direction, it is moving in downward direction. So here now constant magnetic field can be obtained with field winding, and if you apply the mechanical input on conductors, what happen? Conductors are rotating. Now rotating conductors are placed in constant magnetic field. Conductors are changing, varying with respect to space, but magnetic field is stationary, constant magnetic field. Now conductors are rotating, so that rotating conductors are placed in constant magnetic field. So what is the working principle? Working principle is whenever rotating conductors are placed in constant magnetic field, EMF is induced. That EMF is also known as dynamically induced EMF. That EMF is also known as dynamically induced EMF. So this is working principle of DC generator. Now how you can find out the direction of induced EMF? By using Fleming's right hand rule. See, these three fingers are mutually perpendicular to each other. Thumb, middle finger, forefinger, middle finger. See, in middle finger represents direction of magnetic field. Direction of magnetic field. Direction of magnetic field means where the magnetic field is developed? In field winding. So magnetic flux lines are passing from north pole to south pole. So this one represents direction of magnetic field. And armature conductor is rotating in clockwise direction. So here these are the two conductors rotating in clockwise, means this conductor is moving in upward direction. So thumb represents direction of force. So coming to these two conductors, Here this conductor is moving in upward direction, this conductor is moving in downward direction. Now how you will apply the direction of force, direction of motion of the conductor? Here thumb represents direction of motion of the conductor. But coming to this conductor, what is the direction of the motion of the conductor? Downward. Like this we will apply. Here like this we will apply. Why? Because this force is upward direction. So we will represent force like this. Here this force is downward direction, so that here like this we can apply. Like this we can apply. Clear? What is the direction of magnetic field? Flux lines are passing from north pole to south pole. This is north pole, this is south pole. North pole to south pole. So how you can represent? This is the direction of magnetic field. So forefinger represents direction of magnetic field. Thumb represents direction of force. Direction of force. So this is resultant. Direction of force, direction of magnetic field. Here how you can apply? This is direction of magnetic field. This one is direction of force. At this conductor, direction of force is downward. At this conductor, direction of force is upward. Understand? So what is the another finger? Middle finger. So at this position, middle finger, which is leaving away from me. But coming here, direction of force is opposite. Opposite. So that middle finger entering towards to me. Clear? Clear? Here middle finger direction is leaving from me. Here if you apply, middle finger direction is entering towards to me. Entering towards us. Clear? If middle finger is leaving, leaving is representing with cross. Here middle finger is entering, entering is representing with dot. So here if you apply Fleming's right hand rule, if you apply Fleming's right hand rule, if you apply Fleming's right hand rule, Fleming's right hand rule, what happened? This is direction of force, this is direction of magnetic field, and what is the direction of current? This one is cross. Current is leaving. Current is leaving. But coming here, current is entering. Entering is representing with dot. So this one is plus minus. This one is minus plus. Clear? See, this is conductor AB. So here in this conductor, which type of EMF is induced? Cross. In this conductor, which type of EMF is induced? Dot. So let us cross is positive. Here negative. But after getting half rotation, initially this direction is, force direction is upward. But after getting half rotation, direction of force is downward. Now which type of EMF is induced? Dot. Previously this one is cross. After getting half rotation, this one is dot. If cross is positive, dot is negative. Now which type of EMF is induced? Negative. In this direction, here positive. After getting a half rotation, now it is negative. So the EMF induced in the armature conductor is alternating EMF. Which type of EMF is induced? Alternating EMF. Alternating EMF means AC. But what we are discussing? DC machines. So output should be DC. So how you will get DC? By using, see here I will use commutator. This is commutator. This is called commutator. This is called commutator. So by using commutator, we can convert from AC to DC. So what is the function of commutator? Which is converting from AC to DC. So EMF induced in the armature conductor is AC. Here commutator, which is converting from AC to DC. So that DC can be collected by DC supply can be collected by brushes. This is called brush. This is called brushes. See here, commutator is connected to, see, armature conductors are directly connected to commutator. If conductors are moving, commutator is also moving. But brushes are fixed, not moving. Brushes are fixed. So what is the function of brush? Which collect the supply from the commutator. Which collect the supply from the commutator. What is the function of commutator? Which collect the supply from the armature conductors and it is converting from AC to DC. AC to DC. AC to DC. So this is about working principle of DC generator. So in next class we will discuss about working principle of DC motor. Thank you.